the matching, and then what I'd like to do is just kind of work through the review with you. You guys can correct your work with the color pen. And then we want to talk about questions at the end. Thanks, Emilio. Okay, so let's just start with the matching. Raise your hand if you have answer to number 1. So a to the m times a to the n, what do you have, Cal? It's e, right? Because when you have the same base, you add the exponents. So this is e. When I do a matching, a good test taking strategy is just cross out the letter. Don't cross out the whole answer, because if you make a mistake and it's all scribbled out, you won't be able to see it. But e's correct. Okay, what about the next one, Matt? So it's the product rule, right? When you have a product raised to an exponent. B, yeah, I was looking at A. It's each term raised to that same exponent. This is not the best quality, but you guys have your worksheet there, so you can see those, I'm hoping. This is a PDF instead of a smart file, so it doesn't show up quite as well. Yeah, B is correct, so we're going to cross that out. Okay, next one, Ingrid? Yeah, hopefully everybody's got that one down. That's the easiest question on the test. But sometimes those easy questions are the hard ones because it's also really weird. F is correct. Zig, what about the next one? G. G, right. Anytime you have a negative exponent, that means a reciprocal. So G is correct. Good job. Okay, and another power rule. Nadiv, number 5. E. What'd you say? I didn't hear you. E. We did E. Look again. Oh. A. It's A, correct. Okay. So when you have one base raised to an exponent and that whole thing raised to another exponent, it's the original base raised to the product of the two exponents. That's a hard one with letters. It's easier when there's numbers in the problem. Okay, scientific notation. So what's an example of scientific notation? Yeah, David? C. So, and then the last one, not a lot of choices left. Leander? Right. And this is an A here. So same base, but you have a quotient. So you rewrite this as one base. Where did it go? Oh, right there, D. Couldn't find it. Okay. Any questions on that? Are you correcting with a colored pen? Yes. You should be able to do those. Just, you got to sometimes study. That would be, and I don't think I would say this very often, but that would be a great use of flashcards. You know, flashcards in elementary school for math facts can be handy. This class, there's not a lot of place for flashcards because we're usually doing bigger things. But if you took, 5-10 minutes to make flashcards tonight and just went through those, that would be a great way to prepare for matching. Just with the rules from section 7.1 to 7.4. So scientific notation to decimal is what this says, but we also think what we're talking about is to standard. So maybe write that in, please. Because some of these maybe don't end up with a you don't necessarily need the decimal if it's at the end of the number. So that's a little bit different vocabulary, just because I think we just took this from a test generator, which is like a program that just puts out problems, and so it doesn't go with your textbook. Your textbook is using the vocabulary standard form. Okay, so you're either going to change from scientific to standard, or standard 2 scientific? Okay, so let's see. Haley, what about the first one?
6.5
Times 10 to the, well, your decimal would be here. What did you say, 10 to the, look how many times we move that in to get it to 6.5. You had the 6.5, right? Yeah. Did you just count wrong? Yeah, that's what it sounds like. Okay. How about Will, B? 9.3 times 10 to the 7th, right? So you could go 3, 6, 7, right? You don't have to do every little teeny jump. So 9.3 times 10 to the 7th. So what is the requirement for scientific notation? Does anybody remember about the decimal? Yeah, Adam?
There only can be one digit to the left of it.
Yeah, so a way to say that is this number, the decimal part of the number has to be between 1 and 10. Between. So it can't be 1. Well, it has to be bigger than or equal to 1, but less than 10. It could be 1.0, but you can't have 10. So the one digit after the decimal is the most you can have. Okay? Noah, what about the next one?
C, I got 485,000.
So let's see, 485,000. Okay, let's check his work. So you're going 1, 2, 3, 4, 5. So add 3 zeros. That looks good. Any questions on that? Okay. And Cal, what about the last one?
I got.
That's a 7 here. 10 to the 7th power. Oops, you can't see that.
10,030,000.
10 million. 30,000.
Yeah.
Okay, let's check his work. 7 decimal places, right? So 3, 6, and we net another little space, so we need to add 4 zeros. So 1, 2, 3, 4. He's got that done correctly. Comma's in the right place. Good. Xander? Victory. Okay, good. Okay, right. So this is like emphasis. Really, the best way to say the question is, or the directions is just write in scientific notation, which means that you can only have one decimal place. The proper in capitals is just a reminder that just because you multiply by 10 to some exponent doesn't make it scientific notation. It has to have the decimal part of the answer be bigger than or equal to 1 and less than 10. So this is in an exponent type form. We want to fix it. So I would have maybe liked to have seen the directions say rewrite so that the number is in scientific notation.
That makes much more sense.
Yeah, Zig?
You only have one number for the decimal. You will
Let's make that a little bigger. Woo! Wait a minute.
start off with the decimal after the 5 and before the 0.
Right, so you have to move it how many times?
2.
Right.
Then you're going to go back, so you're going to go 6 digits. It would be 1, 2, 3, 4, 5, 6. You can move it back 5 times. And then that will only be 3.
You guys agree with that? So let's think about a different problem, okay? If I had 5.027, oh, that's not what I mean. If I had, let's try that again. If I had 5.027 507 or 502.7, and I wanted to do this. So it's a little bit different problem. This becomes 5.027.
Now you have to move it over.
So am I going to have, what number am I going to have here?
Negative second.
Okay, if this was a new problem, if this was the problem right here and I wanted to put it into scientific notation, what would it be?
Negative second. 5 Negative second. Negative second.
It would be the second power. If this was the whole problem. If this was the whole problem, right?
Oh, okay.
If this was the problem, not problem A, but just this is the beginning problem. Do you see that? Well, that's the question, right? So, if the original problem had the decimal right here,
Oh.
and I had to get it to be in scientific notation there, it would be to the second power, right? So if in this problem it's already to the sixth power, and I'm going to move it 2 more places,
So it's to the 8.
it's going to be to the 8th. Is that helping? Do you see what I'm trying to communicate? It seemed like you were getting a smaller power of 10 here, but you should be getting a bigger power of 10. Yes? You want to try again? Yes. Good idea. And you guys, when I said proper scientific notation, remember this number here has to be bigger than or equal to 1, but less than 10, right? So you only can have 1 digit in front of the decimal place. Okay, so now, what is the difference between this problem and the previous problem?
Well, the power of 10 would be wrong there because it would be, you go all the way back, it would be 6 instead of 16.
So you're going, like, to here, though. Do you want to think about it, or you want somebody else to answer it? So Noah, what would you get, Noah?
8.12 times 10 to the 13.
Right, because we're going the opposite direction 3 places, so this has to drop down to 13. How many people got both of those right? Okay, so at least half of you, that's a good one to go home and study. Yes? Okay, good. So you know what you could do, you guys? You could take smaller numbers at home, and mimic the problem. Like, maybe make this 0.05 times 10 to the 4th, and then put in, let's put a 2 there. Rewrite it as 5.2 times 10 to the what? What would that have to be? 10 to the, okay, so if you think it's 10 to the second, then you could pull up your calculator at home, and you can check to see if they're equal. So you would have to go to a scientific calculator. How many people have that? Yeah, so you could check it. Do you know how you would do that? You would go 10 to the, hold on, this, oh here, my calculator has a button. Let's use that. So 10, and my calculator put the power in first. So 10 to the 4th times 0.052. Okay, and I get 520. And then I can check my work to see if I'm right. So now I would do 10 to the second, even though you could do this with mental math, times 5.2. Of course you could do it with mental math with the numbers I picked, but if you pick a little bit bigger number, you know, it's a good way to practice learning how to use the calculator key for powers of 10. But you get the same answer, so you could always check that way, just to practice getting familiar with how that button works on the calculator. You know, I'm not talking about 20 minutes, but 3 to 5 minutes on that. That would be a good way to check your work. Should we keep going? So it sounds to me like a lot of people need to study that concept, which is a good thing to know before you go home. Okay, Bill Gates. So we already talked about his wealth. Let's see, can you see that back there? Richest person in the United States, he's worth approximately 61 billion. So how many zeros is in 1 billion? Not easy. That's a million. 9, right. So 61 billion is 9 zeros. So if you're still kind of focusing on scientific notation slowly, it's not a bad idea to write that out. Some of you could probably do the problem without writing it out. But that's 61 billion. I need my decimal to go all the way between what numbers? 6 and 1. So that's 3, 6, 9, 10. So you want to be careful when you write this. 6.1 times 10 to the 10th. Did anybody accidentally put 9? Do you see the mistake? Right. And then the decimal notation, remember, we're just thinking standard, right? Standard. So I already wrote that in blue. 61 billion. Well, it's true. This is money, but we're just, for scientific notation, it wouldn't be, I guess we should put that in. I agree. No, yeah, I think that I would not have marked that wrong because I'm really asking you about, can you switch between the forms? It's not really an application problem where the units, I'm checking to see if you understand what the units are. Okay, let's talk about the first one. A positive exponent represents a repeated multiplication. So, Sean, what's a negative exponent represent?
I said a negative exponent represents a reciprocal.
It does. And when we have a reciprocal, I like the way you said that. A negative exponent represents a reciprocal. That's a good question. So if you have for what you guys have learned, like if I had, let's make that a 9 to the negative 2 power, that would be 1 over 9 times 9, right? So it is the same as 1 divided by 9 divided by 9. But later, when you have a negative exponent in the denominator, if I had like 9 to the negative 2 here, does anybody know what that would be? 9 to the second. This is the same thing as 9 to the second. So is that division? Is that division? Not really, right? Yeah, so I think this is a better answer. What I'll do, you guys, is during my planning, I'll finish this up and I'll work them out. There might not be a lot of talking, but I'll post it. And you guys can check it. Okay, so I'm going to go ahead and continue working this out, these problems out. And just so you know, I'll send an answer key home to your email. Okay, on this problem here, we're going to change this back, this problem letter A here, to standard form. So the negative exponent will move the decimal to the left 5 places. So that would change the number to be 0.0000034. And on part B, you go 1, 2, 3, 4, 5, 6 places. And since the original number is much smaller than 7.02, we're going to multiply that by 10 to the negative 6th power. Okay, let's take a look at problem 6. We're going to just try to go through these using the rules pretty quickly. Remember, you can just pause and review, but I'm going to go through and use the rules pretty quickly. So I have the same base. That means I add the exponents. 11 plus 5 is 16. So this is going to be x to the 16th power. For b, let's erase this. You have the same base. So you add the exponents, which would be 2 to the 5th power. But if we take a little bit of time to read the directions, the first part of the directions is write each expression using a single exponent. And then the second part says, if possible, simplify the expression. So that means simplify the expression if it's numeric. Can you write the actual value of that? And that's 32. That's the answer to A and B. So let's scroll down a little bit and take a look at C. So for C, the way to write this with the same base is negative 3 to the 3rd power. But to simplify the expression, since it's numeric, we know that since it's an odd exponent, our final answer is going to be negative. And 3 to the 3rd power is negative 27. Looking at D, don't forget to put a 1 there to help you think about this. So D is just m to the 7th power. E, any number to the 0 power is 1. That's just equal to 1. And for F, you have 3 sets. I'm going to make this a little bit bigger. These are real small. Hopefully you have your worksheet with you, so if you need to, you can look at your worksheet too. For F, this is 3x times 3x times 3x. You can just use the power rule and write this as 3 to the 3rd, x to the 3rd. That would be one of those would be your first step. But remember to simplify, 3 times 3 times 3, that's 27 to the, and x to the 3rd power. That's your final answer. Going to G. This is a different power rule. Same idea though. Since you have an exponent of 3, you have 3 sets of what's inside the parentheses. So x to the 8th times x to the 8th times x to the 8th. So all in all, you have x to the 8 plus 8 plus 8, which is 24th power. Okay, H is a little bit different. It's easier to go back to G and look at what the property was when you have one base raised to an exponent and that whole term raised to another exponent. The shortcut is multiplying those two numbers. So 8 times 3 gives you this 24 here. When you have negative exponents, it is nice to just know that rule. And then you would just have m to the 20th power, because negative 4 times negative 5 is positive 20. All right, so going to I. take a look at I. Here we have a division problem. Let's make that a little bit bigger. This is n to the 7th here. I'm going to just rewrite that. N to the 7th over n to the 4th, in case you can't read that. So there are more n's in the numerator. I'm going to write this out just to remind you of what this means. You have 7 n's in the numerator and 4 in the denominator. So these each divide to be 1. So therefore you're left with 3 n's in the numerator. So we just write that as n to the 3rd. Going back here to the original problem, if you understand that the bases are the same, you could just subtract the exponents. Oops. Subtract the exponents here and jump right from here to the final answer. Let's look at J. Same idea. I know now there's more 3's in the denominator, so there'll be 3's left over in the denominator, and the difference between 10 and 7 is 3, so I'm going to have 1 over 3 to the 3rd power. And I can simplify that, so I'm going to write that as 1 over 27. That's my final answer. If you want to use negative exponents on that, that would also be okay. Your first step might appear a little different, so we can erase this and start it a different way. You could say this is the same as 3 to the 7 take away 10, which is 3 to the negative 3, and that's a reciprocal 1 over 3 to the 3rd, but you still end up with the same answer of 1 over 27. Let's go to the next problem. When you see this old division sign that you used a lot in elementary school right here, I would immediately remember fraction means divide and rewrite this as a fraction. So you would start with this as 8, a to the 4th, divided by 4, a to the 10th. And then let's work through reducing. 4 goes into itself once, and it goes into 8 twice. So we can rewrite this now as 2 a to the 4th over 1 a to the 10th. Now we have more a's in the denominator. We have 6 more a's in the denominator than we do in the numerator. So we rewrite this one more time as 2, and 4 of these a's cancel out with 4 of these a's, and there's 6 left. So 2 over a to the 6th power is your final answer. Same idea here. This is in the numerator, so we're going to put c in the denominator. So if you think about that, that's 4c to the 5th. Let's switch colors so you can see the difference between the problems here. So 4c to the 5th over just c. So c divides into itself once and cancels out 1c up there. So we have 4c to the 4th over 1, but we don't usually leave a 1 in the denominator as a final form, so the final form here would be 4c to the 4th. One thing to keep in mind is this is longer than the test would be. This is lots of extra practice. Okay, moving on to M. Here you would have a good thing to do here is just apply the exponent rule. So x to the second raised to the 8th power is x to the 16th, y to the 24th, z to the 8th. That's your final answer. Similarly, this is 3 to the 4th, d to the 5 times 4, which is 20, and f to the 8th. So we want to then take this 3 to the 4th and rewrite that as 81. 81, d to the 20, f to the 8th. That's the final form of the answer. Scroll down a little. This is the best problem on the test. Anything to the 0 power is 1. So hopefully when you see a question like that, you don't do any work. Just write the answer down. Okay, on this problem here, we have two bases, and so we're just going to add the exponents. 8 plus negative 6 is positive 2, so this is 5 squared, so the final answer is 25. So because we have two of the same base, we add the exponents. One way to think of this is anything to the 0 power is 1, so we just have h to the 7th over 1. So the best way to write that is just h to the 7th. So we're now just doing extra practice. Remember, the test tomorrow will not be this long, just lots of extra practice. So we have the same base of negative 6 here. So we have a division problem, so we're going to subtract the exponents. So 9 take away 7 is 2. So this becomes negative 6 squared, which is positive 36. Another way to think of that is there's more negative 6's in the numerator. So all 7 of these cancel out with 7 of those, and then there's 2 left. And you could think of it as divide by 1, but again, in our final answer, you don't want to leave a 1 in the denominator. Let's see, I think we're about almost to the end here. This one's a little hard to read also. So this is x to the 12th. I'm just going to copy the problem over. Times x to the k power. So same base. You want to add the exponents. So your final form here may look a little odd to you, but just write it like that. Same base, add the exponents, that's all you can do. And the last problem, I'm going to copy that over just so you can see it better. It is d to the a power divided by d to the 3rd power. So rewrite that in fraction form, d to the a over d to the 3. Same base, subtract the exponents, so that would be a take away 3. So your final answer is d to the a take away 3.